Okay, good morning. Today for Algebra 2, we're going to be looking at Chapter 11-3 on probability of multiple events. So in the last section we looked at probability of a single event. Today we're going to look at the probability of multiple events. So there's kind of two different kinds of events, and we define them as dependent or independent. So dependent is where one occurrence affects how a second event can occur. All right. Independent events are where one event doesn't affect the outcome of the other event. So, the classic kind of case is if I have a bag full of marbles, I got 10 red marbles and 10 blue marbles, and I reach in there and I pull out one marble at random and I don't put it back in, and then I pull out a second marble. Those are dependent events because I didn't put the marble back in. So depending on what happened with that first event, it'll affect my probability of pulling out a red marble on the second event. However, if I put it back in between, that's called with replacement, and that would be independent. Because then the chances will be, kind of 1 out of 2, 10 out of 20 for pulling a red marble out each time. All right, so the basic idea with when you have two events, to find the probability that the two events are going to happen either at the same time or in a row, you multiply the two probabilities together. All right, so you find the two probabilities. So suppose I got 1 out of 3 is the chances of the first event happening, and 1 out of 4 is the second event. The chances of having both of those events happen either at the same time or right after one another would be 1 out of 12, because I'd multiply those two probabilities together. Okay, so that's some of the basic idea that we're working with here in this section. So the first one is just simply classifying these as independent or dependent events. So I roll a number cube and then I spin a spinner. So the fact that I rolled the number cube does not affect the fact that I spin a spinner next. Those two are independent. They're not dependent on each other. So those would definitely be independent. Okay. The second one, I pick one card from a deck of 52, and then I pick a second card. So, suppose I pull out the Ace of Hearts on the first one. The second card is going to be changed, the probability by that first event, because there'll be no more Ace of Hearts in there. It doesn't say I put the card back in. So these are definitely dependent events, because the second one's affected by the first one. Okay, so depending on what I pulled out for the first card will affect the second pull. Okay, so that's the answer to the second one. So that's all you're doing, is determining which kind, whether it's independent or dependent for that. Third one, I pick a card from random from a deck of cards and then I replace it. So this is the then replace part. Those are very important words in these kind of problems. The fact that I replaced it back in, my chances of getting whatever card you're looking at is 1 out of 52 for both of them. Okay, so these are now independent. Because it has with replacement. Okay, so that's the key words there. Okay, next one. Big word problem. There are 10 diet drinks, 5 regular drinks. 10 diet drinks and 5 regular drinks. The idea is you're at a picnic here. There are also 8 bags of fat-free chips and 12 bags of regular chips. Suppose you reach in and grab a drink and a bag of chips without looking. What is the probability of getting diet drink and fat-free chips? So I've got two different kinds of events, right? The first one is the drinks. So let's talk about that for a minute. My probability, remember, is I want to find out what's my probability of getting a diet drink. And let's see. So remember, our basic probability is the favorable events over total events, right? Favorable over total. So for the drinks, I've got 10 diet drinks and 5 regular drinks, which means there are 15 altogether for drinks. Now let me look at the chips. I've got 8 bags of fat-free chips and 12 bags of regular chips. And I am interested in the fat-free ones. So I got 8 fat-free. And then there's 12 and 8 together will give me 20. So those are my two probabilities. And remember, if I want to know, what the probability of both of those events happening, I multiply those together, okay? And so I'm going to do this with a calculator. So 8 times 10 is 80. 15 times 20 is 300. And I can punch those into my calculator. I kind of like percentage for probability. It always makes it pretty easy. So this is 0.2666. 2666, not 26. Repeating, which is equal to 26.67%. Okay, so I kind of like the percent, but you can do either. Really, either one's fine. Okay, decimal is also acceptable. All right, so those are my chances. So 26%, about 1 out of 4, right? 25% is 1 out of 4. So those aren't bad for, although 3 times out of 4 you'll be disappointed by the getting the non-diet drink or the non-fat-free chips. All right, so this one, number 5. The same problem as above, except what's the probability that you get a regular drink and regular chips? Okay, so the total numbers are the same, right? There's still 15 drinks and there's still 20 chips. However, the numerators are going to change because now what's favorable changed, right? So there were, let's see, if I had up here, I'm looking at this, and I had 10 diet drinks, which means this one's only going to have 5 regulars. I subtracted those. And then I had 20 chips, and only 8 of them were fat-free, which means 12 of them would be regular. Once again, I'm just subtracting those numbers. I know if I had, right here, 28 chips altogether and 8 of them were fat-free, but now I'm interested in how many were regular. That had to be the rest of them because there was only 2 kinds, okay? So now I got this, so now I can multiply these together, and 5 times 12 is 60. Denominator is still the same, which is 300. So if I was looking for a ratio, you could lop off the zeros there and go 6 out of 30 would be one way to look at it. I'm also looking at percentages. So if I go 6 divided by 30, that would be 0.2 because that reduces to 1/5. Or if I was looking at percent, which is kind of the way I prefer it, 20%. So one of those two answers would be what I'm looking for. Okay. All right. Number 6. This one, a little different. These are like OR problems. The book teaches it a little different than I do. So if you look at that, you can do it their way if you like, but I always like my way. A student can take one foreign language each term. About 37% of students take Spanish and 15% take English. What's the probability that a student is taking Spanish or French? I'm going to highlight that because those are the key words, or, okay? Which means, it's not one, it's really both, right? If I had 5 kids taking Spanish and 3 kids taking French, and I asked, how many kids are taking Spanish or French, you'd go 8, right? Because 5 plus 3 is 8. So that's what changes here. So this one is really pretty straightforward. Probability, we got 37% of students and 15% take French, and I want to know what's the chances of one or the other if I add them together. 37 and 15 is 52%. So that would be one type of answer. Okay, pretty straightforward, right? Or you could give it to me as a ratio. You could go 52 out of 100. Okay, that would also be fine. One of those. That's really all we're looking for. Or 0.52. That would be a third way to represent the same thing. Any of those would be fine answers. That's it. All right, pretty straightforward. Keep an eye for those or words, when they got to read the question, what they're asking for. Okay. Next one. Move this slightly. So a jar contains 5 blue marbles, 10 red, and 4 green marbles. You choose a marble at random. Don't replace it. I'm going to highlight that because that's important. Then choose a second marble at random. So we got a couple questions that are going with that scenario. The first one is, what's the probability of selecting a blue, then red? Okay, so once again, favorable over total. Favorable outcomes over total outcomes will give me my probability here. So let's do one at a time. First, I'm going to do the blue. So let's see, how many marbles are there all together in the jar? I got 5 blue, 10 red, that's 15, and then 4 green is 19 altogether. Okay. And we're looking at just the blues. So I got 5 blues out of 19. Now I pull out the first one, right? And I get a blue, which gives me there are not 19 marbles left in the jar. There are 18 for the second pull, right? Because I pulled one out, didn't put it back in. So now there's 18. So that's important, all right? That's the important part about the don't replace. And the second one, I know what's the probability of getting a red. So I have 10 reds, and I didn't pull a red one out on the first one, so there's still 10 reds for the second pull. So that's my chances now of getting a red one with the second draw. Okay, so these are my two probabilities. I'm going to multiply them together and turn them into a percent, and I'll get my answer. So 5 times 10 is 50. 19 times 18 is 342. And when I divide those, I get 0.146 or 14.6%. Simply move that decimal over. Okay? I mean, you could give me this as an answer too if you want. But 14.6 actually means something to the reader, so that's why I like percentages, 15 times out of 100, basically, you'll get that. 50 out of 342 just doesn't mean a lot to a reader, although, you could always go figure it out, I suppose. So anyway, that's why I like the percentage. All right, next. Selecting a red, then another red. Okay, so same idea, favorable over non-favorable, or it's favorable over total, excuse me. So red, we said there are 10 reds. On the first pull, there are 19 marbles in the bag, right? The second pull, we didn't replace it, which means there's 18 reds left. Sorry, 18 total marbles left. However, there's no longer 10 reds in the bag because I pulled a red one out on the first one, right? Which means there's now 9 reds left in the second draw. Okay, so those are my two probabilities. Now I can multiply those together and I can get my answer. Okay, so numerator 9 times 10 is 90. 19 times 80 is still 342. And if I divide those out, I get 0.26 or 26.3%. So one of those would be good. You can give me the fraction if you'd like, but I really like the percent. Okay. All right, next one. So notation can be a little tricky here. This is the notation. Let's go through one or two of these because you're definitely going to see like this in the book or on your worksheets. A standard number cube is rolled. Find the probability of P stands for probability. So they want to know what's the probability of getting a 1 or an even. So let's see, I got a standard number cube has 6 sides, okay? So that's the denominator. And let's see, how many ones or evens are there on a 6-sided cube? So 1, 2 is even, 4 is even, and 6 is even. Gives me 4 different things. So my chances of getting a 1 or an even is 4 out of 6. And if I divide that out, you get, it's the same as 2 out of 3, 0.66 repeating, or 66.6%. Okay, so one of those would be the answer. Give me the, if you want to make me happy, give me the percent. Next one, the same scenario, except they're looking for the probability of an even or greater than 4. So let's see. There are still 6 sides on a standard number cube. All right, so even 2, 4, 6, and then greater than 4 is 4, 5, and 6. But I've already got the 4 and the 6 in here, so I'm just going to add one more for the 5. Okay, you don't count those other ones twice, you know what I mean? Because it's still a 6-sided number cube, you know. So hopefully that makes sense. Even is 2, 4, 6. I've already got the 4 and the 6 for greater than 4. So actually, greater than 4 doesn't count 4. It's only 5 and 6. But I've already got the 6, so I need the 5. So that's where the fourth one comes from. So this one actually has the same numbers, right? It's 4 out of 6 is still 66%. All right, next one. Q and R are independent events. So once again, these notations, this is probability of Q happening and probability of R happening. So independent events means that they don't affect the outcome of each other, right? So I want to know what's the probability of Q and R happening, which means simultaneously or at the same time. So when you have that, you multiply the two different probabilities together and you get the answer, right? It's just that simple. That's it. Multiply the two fractions. Multiply the numerators together, multiply the denominators together, turn it into a decimal. 2 divided by 15 is 0.13333, which is the same as 13.3 repeating percent. So those are your answers. Okay. And that is my last problem for the day. Hopefully it made a bunch of sense. If you have any questions, please bring them to class. Have a wonderful evening, and I'll see you all soon.